So in the next step we are memoizing the longest common subsequence, that is bottom up approach. We are following it. How to know the size of the matrix? These are the questions that can come. How does it work and the code variation, what is code variation and all. So for it, if there is only function where the dp is not used, means the function n, if there is only one common function and it is we are call function n minus 1, so here dp will not be, we are not using. When there is a sub problem occur, then dp will be used, means in the function n, the one is in recursion, one is function n minus 1 and one is function n minus 2. At this time that we are using dp because there are two functions, so sub problem can occur. See here the function, if I am getting function n minus 3 here, so again here in function n minus 2, after calling it we can get function n minus 3, so here sub problem can occur. So how the dp idea come into takes place, means memoization comes takes place. How this idea comes, see here in function n minus 1 it is coming, so if we can store this in some table, then in later purposes when function n minus 1 here it is come, so we do not have to again rewrite it again, calculate it and again do the recursion and all. We just store the value, we can place it here, and that's all. We do not have to do all the steps again. Function n minus 3, then n minus 4 we don't have to do, because these are already done and is stored in value. So this subpart, this whole subpart get memoized, so a lot of time complexity get cancel out. So in terms of memorization we can do recursive call plus the matrix that store the values in the matrix form. So store it in somewhere I have to do it again, then we have to return what is coming. Okay, so in top down only table, see here the example of LCS xy axyt and ayzx. Here in the LCS, in the recursion part, what I have done, ax y we have to taking this, and if this is not matching with each other, then we will take one ax y and we will take the whole x. Here we will take the whole a y z x, that is the whole ax y and a y z x we have to take. Then again ax y t and a y z, this half part we take. In this two, in one of them we have to remove the last element, and one we have to take the whole. Okay, that is the main funda. So after that recursion again in ax y and a y z, these two we are comparing and it is not matching, then that's why ax we take, and here a y z x whole thing is we are taking it. Here it is matching, so you will return the value. So see, again in this part ax y we take and a y z, this whole we take, and this half, this last value excluding last value we are taking. And here also see, here also ax y t a y z, here we take ax y and a y z whole value. So these two values become same. If I store this value, then we do not have to calculate this. Okay, this is called memoized. We memoizing this is called memoization. Okay, टेबल जो बन के है, टेबल जो बनाते हैं, जो वेरिएबल रिकर्सिव कॉल में चेंज हो रहा है, m and n आर चेंजिंग, मीन्स m and n आर डिक्रीजिंग. सी इसका लेंथ m है, इसका लेंथ n है, तो m माइनस 1 ये कर दिया, इधर m माइनस 1 हो गया और ये पूरा ले लिया n, तो 1 is decreasing, no, so it is changing. So we have to make the table m and n. So how we will make the table, that's the question. So here is the answer. The table size will be n plus 1 and m plus r. N is the row and m is the column. Okay, so when we can store the maximum n minus 1 and n minus 1 in the matrix and initialize the whole matrix with minus 1. How we can initialize the whole matrix with minus 1? In C++ we use main set, and in Java we use we use a for loop I less than equal to row. Okay, then arrays dot field each element of the row with minus 1. Okay, then the whole array will be means the whole array will be done with initialized with minus 1. So first of all, the do not put t in the LCS part, because that's a lot of confusing and lot more thing why we should recurring the t again and again. So we taking a global static. First of all, before the main function we will global static in t initialize the t, then in the main function we will initialize the t with minus 1. Okay, then we should write the function here. Here we have to check if the value is m equal to 0 and n equal to 0, then return 0. This is the base condition. Then we have to check if t of m and n not equal to minus 1. अगर इधर minus 1 नहीं है, वो चेंज हो गया, अगर 5 हो गया तब क्या होगा, तब रिटर्न करेंगे वो वैल्यू, रिटर्न t m और n. चेक इफ minus 1 वैल्यू इज नॉट देयर, देन रिटर्न द वैल्यू. minus 1 वैल्यू नहीं है तो रिटर्न कर देंगे. ठीक है, तो ये तो हमने किया था रिकर्सन में. LCS 1 प्लस LCS जो लेंथ कैलकुलेट हो गया है वो इसके लिए 1 है, और फिर से जो बाकी है उसके लिए LCS x y m minus 1 n minus 1. तो इसको तो स्टोर करना पड़ेगा t m n में. तो मैं टेबल में स्टोर कर दिया t m n में वैल्यू को जो रिटर्न कर रहा है, और ये वैल्यू को भी स्टोर कर दिया मैक्सिमम का. फिर हमको लास्ट में क्या रिटर्न करना पड़ेगा, लास्ट में रिटर्न करना पड़ेगा t m n. वी हैव टू रिटर्न द t m n वैल्यू. ओके, in last for this functions. Therefore the LCS recursion part with the table was confirmed. There are some change, that's why there is a code variation, that is the code variation. Okay, in the recursion part there is some change because of storing the table. By storing the table we are doing the change, and by returning the value of the t m n n. That's the main part. The Memoized version of LCS is this, and therefore when two or more function, if I sum up the LCS Memoized version, when two or more functions call happens, then t of n minus 1 and f of n minus 2, that then dp will take place. And sub 3, if we store and use it when needed, so we make a table and initialize with minus 1. That's the main motto of memoization and dp.